Hi, I'm Doug Kriebel. If you're involved in pumps, sooner or later you will have to step a curve. This is the term given to determining new conditions for a pump when you have changed either the impeller diameter or the speed of the pump. There are several reasons to do this. Maybe the existing pump was oversized, which is very common, or maybe it was undersized, or the system changed, or you want to use an existing pump in a new service. Whatever the reason, you need to design the most efficient and reliable combination of impeller diameter and pump speed. Centrifugal pumps follow what are known as the affinity laws. Simply stated, the flow at the new diameter is directly proportional to the change in diameter. The head varies as the square of the change in diameter, and the horsepower as the cube of the change in diameter. The same relationship applies when changing speeds. The flow change is directly proportional to the change in speed. The head changes as the square of the change in speed, and the horsepower changes as the cube of the change in speed. With the advent of variable speed drives, this relationship is used a lot for pump control. Let's look at two applications to illustrate these laws. You have a pump with a 5.54-inch impeller and want to install a 4-inch impeller. What does the 4-inch impeller curve look like? You pick a point on the 5.54-inch curve, say 100 GPM at 100 foot TDH. You then calculate the 4-inch impeller point by multiplying 100 GPM times the quantity 4 divided by 5.4 equals 72 GPM. And 100 foot TDH times the quantity 4 divided by 5.54 squared equals 52 foot. Plot this point. You can plot more points and draw a curve to match the points, or use a French curve to draw a parallel curve to the 5.54-inch curve through the 4-inch point. The same laws apply to changes in speed. Oftentimes you have a curve at a given speed, usually a synchronous motor speed, and you want to know what speed is required to get a new set of performance. This is done by trial and error. In this case, you have a pump with a 5.54-inch impeller running at 3550 RPM. You want to hit 72 GPM at 52 foot TDH. Rather than trim the impeller, you want to use a VFD. What speed is required on your VFD? First, plot the new point and assume a new, lower speed using the curve speed and the assumed speed to calculate a point which should then fall on the 3550 RPM curve. Let's assume 2400 RPM. Then 72 times the quantity 3550 divided by 2400 equals 107 GPM, and 52 foot times the quantity 3550 divided by 2400 squared equals 114 foot. As you can see, it is above the curve, so the speed change was too much. So assume 2550 RPM. By doing the same calculations, it now falls on the curve, which means the assumed speed of 2550 RPM is correct. Sometimes this could take a few iterations. Today's pump selection software will do these calculations for you. If you don't have access to them, contact a qualified pump supplier. This is an illustration of a pump with various speed conditions. We know this information will allow you to make decisions to design more efficient and reliable systems, and if you need help, we're here for you.